right, we are going to start chapter 1.9 today, which is graphing quadratic inequalities. So we're coming full circle back to our beginning of this chapter where we were graphing inequalities. Quadratic equations, and now we're graphing inequalities. So you might remember from Algebra 1, graphing inequalities where it has a greater than or less than or a greater than or equal to or less than or equal to. And it's basically going to be the same process, but now we're working with these parabolas instead. So to graph a quadratic inequality in either vertex, intercept, or standard form, follow the following steps. First step is you're going to graph. So graph the parabola using either a table or the key points. So just like we did in chapter 1.1, you can use a table from your calculator or use those key points, the vertex, the axis of symmetry, and then you can find those x-intercepts or the y-intercept and then go on the other side of the axis of symmetry. You want to make the parabola dashed for inequalities with less than or greater than, and you want to make it solid for inequalities with less than or equal to or greater than or equal to. This is the same as in Algebra 1. When you graphed linear equations, it was a solid line if it was greater than or equal to, greater than or, and equal to or less than or equal to, and it was dashed if it was less than or greater than. So then step 2 says to test a point xy inside the parabola to determine whether the point is a solution of the inequality. And the third step is to shade the region inside the parabola if the point from step 2 is a solution. Shade the region outside the parabola if it is not a solution. So let's look at an example here. Example 1, we have y is greater than x squared plus 6x plus 4. I believe I gave you all of these in standard form, including on your homework. So as a reminder, when you're in standard form, it's y equals ax squared plus bx plus c. Your axis of symmetry is x equals b over 2a. And your vertex is that point, comma, and then if you plug it in to your equation. Okay, so that's how you're going to find these. And then you can also just make a table if you would rather do that. That's fine. So let's start with example 1 here. We have y is greater than x squared plus 6x plus 4. I want to remind you how to put this into your calculator. So x squared plus 6x plus 4 in your calculator. Skip for now, skip anyways. Go to y equals. And so I've literally already forgotten the equation. It's x squared plus 6x plus 4. So we have x squared plus 6x plus 4. If you hit second table, you can scroll through your table here. If you need to change what you're counting by, it's second table set or second window. And this second section is what you want to change to a 1 or a 0.5. Remember, you can find your axis of symmetry by finding where it starts to repeat. So I see at 3, it's at -5, and around that, it repeats. So I can make my table here just using my calculator and having this plugged in my table. Once you have that, make sure that you plot enough points to make this graph nicely. But then you can use the key points as well. So I didn't give you a table here, x, y. We said that the axis of symmetry is at -3. You know what I just realized? This should be negative. That should be negative. Sorry, I forgot the axis of symmetry is x equals -b over 2a. So -3, and then our y was -5, -4, -5, -2, -1. Just remember, count 2 on either side. So -4, -4, -1, -1. It's been a while since we've done these. So our vertex is -3, -5. Our axis of symmetry is the x. It's at -3. So notice here, my inequality does not have an equal to, so this is going to be dashed. So start by making your points. I'm going to start by making my vertex -3, -5. It's right here. The axis of symmetry runs through that. Remember, Notability actually has a great tool for this. It has this little pencil thing. So you can make, oops, make it a little fatter here. So if you make this curve, right, just make sure you plot enough points, but you can make a dashed line that way. So then -4, -4, -2, -4, and at -1, -1, and at -5, -1. Okay, so once you have enough points, then go to your dashed pencil, get a little bigger if necessary, run through, and I think you can just hold this down. Maybe it'll make a nice one. Notability is pretty great for this. Oh, just kidding. Doesn't like that. Yeah, it's going to do a straight line. All right, so that is step 1. Step 2 says to test a point inside the parabola to determine whether the point is a solution. So try and test an easy point. I'm going to test right here at -3, 0. So testing at -3, 0. And what it means to test is that you're going to plug that into this inequality. So this is my y, this is my x. So I have 0 is greater than -3 squared plus 6 times -3 plus 4. That's what it means to test this. It's not a great place to do this. Good thing we can zoom in, I guess. All right, so when I test this, I have 0 is greater than 9 minus 18 plus 4. This would be -9, so this is 0 is greater than -5. That is true, which means that this is a solution. So I'm going to shade in this area. Okay, so if it's true, you shade in wherever your point is. All right, let's test or try another. So part B, we have y is less than -x squared minus 4x. Again, you can put this into your y equals. I think that's probably the easiest way, or you can just plug it into your equation. Let's check -x squared minus 4x in our table would make a table that looks like x, y. I see symmetry around -2, which means I'm going to go 1 on either side. So at -2, it's at y equals 4. At -3, it's at 3. At -4, it's at 0, and so on. So then my vertex is at -2, 4. My axis of symmetry is at -2. When I graph this, I'm at 0, 0, -1, 3, -2, 4, and then on either side. Again, this is a less than, so it needs to be a dashed line, not a solid line. And then I'm going to test a point. So here I'm going to test right here, which is -2, 0. So testing at -2, 0. My y is 0, my x is -2. I like to use 0 when possible, just because it makes your life easier. Careful with your signs here, though. Can't win with where I'm putting this. Minus 4 times -2. So this would be 0 is less than, this is -2 squared is 4, but then that negative is waiting on the outside, plus 8. So we have 0 is less than 4. This is true again, which means I'm going to shade inside the parabola. All right. Example C, I have y is less than or equal to x squared plus 2x minus 8. So again, you can just put this into your calculator if you'd like, x squared plus 2x minus 8. And you can make a table. We can also test this. Let's go ahead and test this with the axis of symmetry, just the algebraic way, because I want to make sure we all remember how to do that. So it would be x equals, this is my axis of symmetry, x equals -2, because it's negative b, over 2 times my a, which is 1. So it's x equals -1. If that's my axis of symmetry, then my vertex is plugging -1 in for x. And here you can almost treat this as an equal sign, really, but doesn't do much. So this would be 1 minus 2 minus 8. So I would get y equals 1 minus 2 is -1, so it'd be -9. So then my vertex is -1, comma, -9. It's been a long time since we had to do that. Then you can also find some key points. I honestly think the table is just easier, but you could plug in 0 for your y and 0 for your x and solve to find those x-intercepts or y-intercepts. I'm going to go back to the table just because it's faster. So we have -1, -9. This would be -2, -3, 5, -8. So when I graph this, at -3, I'm at -5. At -2, I'm at -8. At -1, I'm at -9. 0, back at -8, and then at 1, I'm at -5. Okay, so now this is less than or equal to, which means it's going to be a solid line now. So the other ones were dashed. This one should be solid. And I'm going to test my favorite point to test, 0, 0. Anytime you can test it, that is the best one to test. The only time you really can't test it is if it's actually on, if the parabola runs through 0, 0. So by plugging in 0, 0, I'll have 0 is less than or equal to 0 squared plus 2 times 0 minus 8. So I think you can see why 0, 0 is the best to test. 0 less than or equal to -8. That is not true. 0 is greater than a -8. So when it's not a solution, that means you shade the other part. So I'm going to shade around the parabola where I wouldn't ever touch that point. On Go Formative, your shading is just going to be a scribble, basically. Just don't draw over your parabola. I'll figure it out. Part D, we have 2x squared minus 8x plus 1. So 2x squared minus 8x plus 1. If you go to the table here, I can see my axis of symmetry. So you have x, y. Should try and do this on your own, but your vertex is 2, -7, so your axis of symmetry is at 2. 1, -5, 0, 1. 5, 1. So my vertex is at 2, comma, -7. My axis of symmetry is at 2. Again, this is an equal to, so it's going to be a solid line. So I go over 2, down 7, 2, 4, 6, 7. Over 1, down 5, 2, 5. At 0, I'm at +1. And I'll connect with a solid line. All right. So we did not run through 0, 0, so I could test that, but I'm going to stick to what the book says, and we're going to test inside. So at 0, 2. Oh, I have room to test up here. So we're going to test at 0, I'm sorry, 0, 2, geez, negative 2, 0. So I have 0 is less than or equal to 2 times negative 2 squared minus 8 times negative 2 plus 1. So this is 0 less than or equal to negative 2 squared would be 4 times 2 is 8. This would be a plus 16 plus 1. I think we can see that this is going to be true without even doing the math here. 8 plus 16 plus 1 is 25, and that's definitely true. So I'm going to shade inside like so, because it is a solution. So that's graphing these quadratics. All right, now we have one other skill here, and that's graphing a system of quadratic inequalities. So your steps here are that you're going to graph the first graph, you're going to graph the second one, and then identify the region where they're both true. So basically this is like 4 problems. I'm going to color code my work, so I'm going to do one in red, one in purple. So this is going to be my first one, and this is really easier to make the table here. So it'd be negative x squared plus 4. If I look at my table here, try and center it around your axis of symmetry, which for this one is 0. At 0 and 4, negative 1, negative 2, 1, 2. So it's at 3, 0, 3, 0. And then this guy, I like to make both of my tables first. Then I just graph in one go. So this is x squared minus 2x minus 3. When I graph this one, my axis of symmetry is at positive 1. And my vertex is at 1, negative 4. It's negative 3, 0, negative 3, 0. Okay, so I'm good to graph now. This is going to be a dashed line, and this is going to be a solid line. So graphing my red one first, I go to 0, 4 for my vertex. At negative 1, I'm at 3. Positive 1, I'm at 3. At negative 2, I'm at 0. At positive 2, I'm at 0. All right, solid line. Okay, I'm going to shade after as well, so I want to graph these two first, and then I'll test, and then I'll shade. Actually, that's not a good idea. Let's shade first, just because it might get confusing for the notes purposes. So, testing a point, let's test 0, 0. So into that first equation, I test 0 is less than or equal to negative 0 squared plus 4, 0 less than or equal to 4. That is true, so I'm going to shade inside. And I'm going to shade with the red color, because I want to see where this is both true. So I'm going to have to erase some of my shading at the end. All right, so that's the first one. The second graph then, I'm going to plot my points. So at 1, we're at negative 4. At 2, we're at negative 3. At 0, we're at negative 3. At negative 1, we're at 0. And at 3, we're at 0. This is a dashed line, so let's go ahead and make this dashed, a little thicker. Okay, and then I'm going to test a point. I can actually test 0, 0 again, because it's still in there too. So 0 greater than 0 squared minus 2 times 0 minus 3. 0 greater than negative 3. That is true. So I'm going to shade where 0, 0 is. Now my actual solution is where these are both shaded. So I'm going to shade for a third time right here where they're both shaded, and then erase my other shades. All right, so this is the solution of the system. It's just that little area where they're both true. Let's try one more. Part B, if y is greater than x squared minus 3, y is greater than or equal to negative 2x squared plus 4x plus 2. So let's graph this first one first in red. So it's x squared minus 3. Put that into my table. and I get this table. My axis of symmetry is at 0, -3, -1, -2, -2, 1, 1, 2. And then my second one is at -2x squared plus 4x plus 2. So for this graph, second table, my axis of symmetry here is at 1. And that's where it repeats around. At 1, it's at 4. 0, we're at 2. And at -1, we're at -4. All right, so when I graph this, graph my red one first, this is going to be a dotted line. So I plot my points 0, -3, 1, -2, and at 2 I'm at +1. All right, and then a dotted line. Back away. We can test 0, 0 again. Great when that happens. So it would be 0 is greater than 0 squared minus 3. 0 is greater than -3. That is true. So I'm going to go ahead and shade inside the parabola. My second equation is going to be a solid line. So I'm going to start with my vertex, which is at 1, +4. Then at 0, +2. And at -1, -4. Around the sides. Here we go, solid line. I can test it 0, 0 again. So I have, if I plug in 0 here, 0 is greater than or equal to -2 times 0 squared plus 4 times 0 plus 2. So this is 0 greater than or equal to, that'd be 0, and I just have 2. 0 is not greater than 2. So since that's not correct, really you should extend these lines all the way to the edge. Since it's not correct, I'm going to shade outside of that parabola. Outside of where the 0, 0 is. Right, so hopefully you can see where these are both true. These are both true. Oops. Right here. So remember, that is the actual solution. So really you want to erase anything that's just the individual ones, because your actual solution is where they're both true. So that's graphing inequalities. It's tying on to a lot of things that we did before. If you have trouble with your calculator, you can always turn to Desmos to help you out with this. But then on Tuesday, make sure you ask me how to use your calculator, because obviously you can't use Desmos on a test or on the ACT or anything like that. If you do have questions, feel free to send me a message on GoFormative.